Hello all, welcome to part 3 of the buffer overflow video series. In this video, we will look at how we can go ahead and execute the shell code which we created in the last video in a C program. So let's quickly write the code for that and then we will go about explaining how it works. So we've written this. Now let's actually go ahead and compile this program. And if you remember, the return value which we had specified in the exit routine was 20. Let's run this program. Let's look at the return value it just left behind. And if you notice, the value is 20, right? So the program is working, but the question is, how did all that piece of code which we just had a look at come together? So for that, let's go ahead, load this into GDB. And let's first of all refer back to our slides. So in the last video, what we had shown you, actually the first video, was that whenever you're inside a function, then space is allocated first for the local variables on the stack. Then after that, you have the old value of EBP, and then finally the return address to which the instruction pointer to be set once the current function returns. So let's actually go ahead and disassemble the main routine. This is where it is. Now the question really arises is that when this program is going to execute, which is the first function which is actually called? Is it main or is something else called before that as well? Well, let's actually do the following. First, let's set up a breakpoint. Let's set a breakpoint on line number 12 and let's run the program. So we've hit our breakpoint. Now at this point, logically, the point is how is the stack arranged, right? Because that is going to answer where the return address is, etc., if there is one at all. So let's go ahead and examine the stack. Okay. So this is where the top of the stack is currently pointing, and these are the 4 bytes which are stored on the stack, consecutively adjacent to each other. Now let's look at the value of the return pointer. So this is the value of the return pointer, and as expected, because the return pointer, the ret pointer, is actually a local variable, it is stored on the stack, right? And as it is the only local variable which was defined, it is stored on the top of the stack. Now, which actually means that this is a possible EBP and this is a return address. Now the question is, if main is the first function, then where is this return address actually pointing to? So let's disassemble this return address, code at this return address. And we notice is that we are in the libc underscore start underscore main function. Now what is this function? Well, very simply put, libc underscore start underscore main is what is responsible for setting up the entire environment for a program and then finally calling the main function. And when main returns, libc does, the libc start main does the rest of the cleanup. So what has happened is libc underscore start underscore main has called main, and because it called that, the return value as well as the EBP was stored onto the stack. And then basically the main function started executing. So when we return from the main function, we would once again go back to the place in the libc underscore start underscore main function where we left off, right? So let's go ahead now and once again look at the top of the stack. So the first 4 bytes on the top of the stack are nothing but the value of the ret pointer. Then we have EBP and then the return address. Now what we ideally want is to be able to overwrite this return address. So let's look at our code. Let's open up the program. So if you notice the next instruction, what does this instruction actually do? So what it does is basically, first of all, takes the location where the ret pointer itself is stored. What would that location be? It is going to be the top of the stack, right? And this is where it points to. Then what it does is that it adds 2 more integer pointer distances to it. What does this mean? It basically goes ahead and adds 8 bytes to this, which is going to make the current value of ret point to this memory location, which, as we discussed previously, is nothing but the return value. Now ret is pointing to the beginning of this memory location, and in the last instruction what we do is go ahead and replace this value with the address where the shellcode is present. So let's actually step through the program. Now the first instruction has been executed, and if we look at the top of the stack now, you will notice that the ret value is actually pointing to 8C, right? Top of the stack is 84, which means we added 8 bytes to it in order to make it point to this memory location, which is the return value. Now the next instruction is going to override the return address with the address of the shellcode. So this is the return address. Let's actually print the address of the shellcode. So this is actually the address of the shellcode, right? So let's step through this instruction as well. And now if we go ahead and print the shellcode, print the top of the stack, you'll notice is that this value has been overwritten by the address of the shellcode. Now what is going to happen is when we continue, as soon as the main function returns, instead of going back to the libc underscore start underscore main routine, we are going to be hitting this, which is the beginning of our shellcode. And if we disassemble this memory location, we will notice that this is the shellcode which we have actually added onto the program. So let's actually continue. And now if you will notice, the program has exited, right? So this is exactly how it is possible to go ahead, inject shellcode into a program and then have it executed. Now this is a very simple demo. In the next video we will look at how to go ahead and create more useful shellcode. So as you can clearly see, just writing the routine for exit and converting it into shellcode is not of too much of help. We would ideally want that the routine which can spawn a shell should be in the shellcode, and then we should go ahead, place that shellcode onto the stack, and the return address should point to that so that a shell will be spawned. Well, it's probably going to take a couple of more videos till we advance to that section. So please keep watching. and please leave behind your valuable comments in the box below. I would love to hear from you. Well, that's all for this video. Thank you.